Almost done. So number 15, the lengths in centimeters of the sides of triangle ABC are as follows. AB is 15, BC is 8, and CA is 15. So if ABC is similar to XYZ and YZ is 10, which statement about the side lengths of triangle XYZ are true? So two things you can do. You can draw your triangles. You can draw two of them. And make sure you label them the same way. So if you label it A, B, C, then this one has to be X, Y, Z. They have to be in the same position, just like we numbered them on number 1. So it says the length of A to B is 15, B to C 8, and C to A is 15. And we know that Y to Z is 10. So what we can do is just set up the corresponding sides. So we're looking for, A says X and Y equals X and Z equals 12 because the scale factor for dilating the triangle is 4 to 5. 18.75 because the scale factor for dilating is 1.25. So they're all asking about the scale factor. So really one thing we can do, since Y to Z, or 2 to 3, was 10, we can take that new number and divide B to C, since that was our old. Those were the same side lengths. So we can take our new side length and divide it by our old. So 10 divided by 8.
1.1.
Okay, so then our answer has got to be B because that's the right scale factor, 1.25. And number 16, triangle ABC is shown below. If ABC is dilated to create A prime, B prime, C prime, which statement is not true? So for a dilation with a scale factor of 3, the orientation, so the direction it's facing, so for a dilation with a scale factor of 3, the orientation of the vertices will be the same. Well, that's true. If we're doing a dilation, if it's transforming by dilating, the size is just changing. Nothing else is changing. So that would actually be true. We're looking for one that's not true. B, for a dilation with a scale factor of 0.7, the orientation of the figures will be the same. Same thing. For a dilation, all that's changing is the size. So the orientation won't matter. And it will be the same. That is true. So C, for dilation with a scale factor of 2 3/4, corresponding sides between triangle ABC and A prime, B prime, C prime will be congruent. So basically it's saying if you dilate a figure by 2 3/4, the sides will be the same. Not so much. We'll put a star. And then D, for dilation with a scale factor of 9.3, corresponding angles between ABC and ABC will be congruent. What did we say about angles when we're dilating or changing figures? They don't change. Remember that. Angle measures don't change. You will still have the same angle measure from one figure to the next. So it's got to be C. This last one for everybody?
Mm-hmm.
Yay. Okay. Figure A is transformed to create figure B as shown below. So figure A is our old, figure B is our new. Which statement about the triangles is true? So A says figure A is rotated 270 degrees clockwise to create figure B. And figure A and figure B will not have the same orientation. So, seems like that's true. They'll not have the same orientation. However, what does this look like to you? What kind of transformation? It looks kind of like a mirror separating them, right? So that would be more reflection. So it shouldn't be a rotation. Then B says figure A is reflected over the y-axis. So far, so good. To create figure B, corresponding sides and corresponding angles of figure A and B will be congruent. So far, so good. They'll be the same size, same shape. They're reflected over the y-axis. C, a figure is rotated 90 degrees counterclockwise to create figure B. Figure A and B will have the same orientation. Well, just from that bottom line, they won't have the same orientation. So we can get rid of C. Figure D, figure A is reflected over the y-axis, that's true, to create figure B. Corresponding angles between A and B will not be congruent. So the first line up here, that's good, that's actually true. But what's wrong with this bottom line? Corresponding angles will not be congruent. What have we been talking about the whole time? Your angles will be the same. Angles will be congruent. The side lengths is what changes. So angles will always be congruent. So B, final answer. That's a lot of red. Okay, that's it.